Honor of National Rock Collecting Day, which is September 13th. I thought we'd do it before instead of after, so I did it today even though we're not quite to September yet, but close enough. I didn't even know there was a National Rock Collecting Day, but I'm glad there is. So there are 3 types of rocks. Anybody know what the 3 types are?
Oh, now I have a brain fart. Igneous, metamorphic, and sedimentary.
Exactly.
Very good.
So we're going to start with sedimentary. Sedimentary are rocks that are formed from layers. It's made from weathering, chemical or mechanical weathering. There are 2 types. There's clastic and non-clastic rocks, sedimentary rocks. Clastic means that it's made of clasts, which, you know, that really helps, doesn't it? So clasts are any pieces of rock or geologic material. Sorry, I ate a piece of pineapple and I think it burned the back of my throat or something. Clastic is just any piece of geologic material that has been broken off from a host rock. So it can be a chunk of sandstone broken off of sand. It can be a piece of feldspar, a piece of quartz that's broken off of a piece of granite. Size doesn't matter, it's just broken off from a larger piece. So, but once it's broken, then it's categorized by size. So boulders are 256 millimeters and larger. Did you know there was a definition for a boulder?
No.
There is.
That's good to know.
So how many feet is that?
256 it's about a foot.
Okay.
Oh, really? I always thought boulders were bigger than
No, anything bigger, a foot, and 256, well 250 millimeters is exactly a foot. So just slightly bigger, probably with rounding is probably very close to a foot. So, and larger. Cobbles are 64 millimeters to 256 millimeters. Pebbles are 2 to 64 millimeters, also called a granule. Sand is 0.063 millimeters to 2 millimeters. Very specific. Sand is a very specific size. Silt is 2 to 63 microns. So that's thousandths of a millimeter. And then clay is 0 to 2 microns. So very, very, very small. In fact, clay, when you find moist clay in the ground, if it's not consolidated, it's just loose chunks of clay, a geologist used to just chew on it to see, because you can chew on it like gum and it'll just mold around in your mouth. And anyway, you could tell what kind of clay it was by that. So, ew. I've tried it a few times. It just makes
Taking licking rocks to a new level.
Right? I've tried it a few times with some clays that they just kind of bleh in your mouth. So I don't know. Lithification describes the process of going from a non-consolidated rock or non-consolidated material like sand or silt into a rock. And so you can do it by compaction or cementation. So you can have sand that is out on the beach. That's not a rock, obviously. It's just sand, and but it can be compacted. And when you get it compacted, it turns into sandstone. If you compact it even further and further and further deep, then that sandstone metamorphoses into quartzite. So, mudstone. So there's only 3 basic types of sedimentary rock: mudstone, claystone, and shale. So I think that's a bit of an oversimplification, but it works. So sandstone is 15% silt or clay, and the rest of it is sand. And when you have that, it's called a wacky. I'm not making that up. It's literally called a wacky. W-A-C-H-E. You can have a green wacky, a gray wacky, blue wacky, a lithic wacky, a feldspathic wacky, a quartz wacky, and just wacky. And I'm not really making those up. That's really a thing. Wookie, right? And then you can have conglomerate and breccia.
Sure.
So the difference between conglomerate and breccia is very fine. So I'm going to pass around this is a conglomerate. So you can see the pebbles that makes up the conglomerate are very rounded. And they can be even way more rounded than this, way more rounded. They can be more rounded than this. Or a breccia is when they're very angular shaped, they're very triangular shaped because they're all shattered and then we cement it back together before they round. So that's a conglomerate. Show that there. Pass that one around. All right, so here is shale. So shale is mostly clay. I'm gonna pass this around, and the one thing about sedimentary rocks is that they tend to hold fossils. And so here's a trilobite. So we can date the trilobites by the rock, and we can date the rock by the trilobites. A little bit of both in this case. So that trilobite is an Elrathi king guy, and it's about 550 million years old. So just over 500 million years old. When this is from Utah and down by Delta, and when these were alive, they were the apex creature of the planet. There was nothing that lived on land. There was no plants, no animals, nothing lived on land. These were the biggest and baddest creatures on Earth. And Utah then, was what we call Utah now, sat on the equator and was turned 90 degrees counterclockwise. Here's some sandstone. This is not a very well developed sandstone. I think it's kind of pushing into almost a quartzite. It's very hard and brittle, but it's got trackways where some creature crawled across there. A few of them did it. So turn it in the light, you can see their little trails as they go across. Another one that gets trapped in sedimentary rocks is petrified wood. This one's from where we're going next weekend.
Mm-hmm.
Yeah, it's down Hurricane Mesa. So this is some of the beautiful wood that comes from down there. Just put them on the floor. This is a horned coral. This one is from Big Cottonwood Canyon. This one I collected many years ago. You can see when you polish the end, you can see that it's a horned coral. Horned corals like this got up to about 1 foot long. Some of them a little bit longer from China. The Utah ones, I've had Utah ones that were black horned corals from the lakeside, out by Dell on the way to Windover, that were 10 inches long. So, but they're very black. The red horned corals that come from up by Camas are the same thing, but they're red because they have chalcedony in them.
So is that considered a rock?
It is, yeah.
Sedimentary
rock, yep. Limestone is one of the non-clastic rocks, sedimentary rocks, and when we say non-clastic, it's not made up of particles that were transported from someplace else and deposited. It's made up of rock that was altered in place. So limestone is often, and dolomite, or dolostone, both of them. So some people call this limestone, and the gray in there may be limestone, but the majority of the rock is dolomite. So here in Utah, it's called zebra marble.
Like zebra stone, is that the
Same thing, yeah.
Okay.
So this is the same thing, but with the zebra stripes much larger. So what happens is you get the limestone, the black here, and it gets cracks in it, and groundwater runs through, dissolves part of the limestone, and redeposits it in the cracks as calcite. And so that's what this is. And the dolomite one, wherever that went, the zebra stone, that one is deposited and probably altered so that it's that way instead of deposited that way. Some more fossils in limestone. These are from down by Nephi, big ammonites in the rock. We're doing the light ones first so we can get to these big ones. Here is a chunk of ammonite. This is just a part of an ammonite. This is from here in Utah as well. This is from down by Desert Lake by Huntington. One of the trips we go into.
I can't imagine how big the actual.
Well, so these ones there only get up to about 2.5 feet across, 3 feet across on some of them. Some of the ones from the Four Corners area reach 6 feet across. So you can see the horns on there.
So that's a glorified snell?
Yep, that's exactly. It's actually more like a chambered nautilus because it had chambers in there. It has the sutures with the chambers in it. So what causes sedimentation is the weathering. Like I said, we can have mechanical weathering. That is simple. You have gravity, water, wind, ice, and biological processes such as humans. causing things to be disturbed and moved. Chemical weathering is the chemical processes such as acid rain. That's a big one. Oxidation, you can have Ron. You can have oxidation, that's where a mineral absorbs oxygen and basically rusts, and that can alter things around it as well. It can also cause things to either expand or shrink, and when that happens, then you have mechanical weathering. And you can have dehydration, where a rock bed dehydrates, it loses its water and its moisture, and so then it collapses and causes, again, mechanical weathering, but it's caused by chemical weathering. Bauxite, this is another one that's done by non-clastic. This is goes through a process of alteration. So bauxite is not only is it kind of interesting to look at, it looks like it's got mold or warts or something, but this is our main chief ore of aluminum in the world. Sorry. Iron stones is another one that is deposited non-clastically by chemical processes. This is an iron stone. And Moki marbles are the same thing. This is the same thing as a Moki marble. It just doesn't have the sandstone in it, and it's not round. It's made up of these globulars. And this is done by groundwater running through the red sandstone. It dissolves part of the iron that's in the red sandstone. The red in the sandstone is caused by iron oxidized iron. And so it'll dissolve part of that and gather it up, and then it will literally blow a bubble underground when it can't hold any more of the iron in solution. And that's what causes the Moki marble. This was freestanding, so this was probably done by water. And if you look at it, you can see how water would be running across this and deposit it on top of something. So when they're hollow like that, they're called a skull.
The way they got aluminum anciently, this had to be hit by lightning.
Uh-huh, yes. All right, diatomaceous earth is another one that is made up of diatoms, basically plankton that settles into thick beds, and then it's actually quite useful, especially if you're a gardener. Diatomaceous earth gets rid of your insects, so we put them in our raspberries so we don't have to put chemical insect repellent in there. We can put diatomaceous earth in there and it gets rid of all the insects. And it does that because the diatoms are very, very, very tiny, microscopic, and they're made up of, if you took 4 nails and welded the tops of the nails together to make a pyramid like this, and then one sticking up like that, that's how these diatoms are. They're very pointing like that. No matter which side they land on, there's always a point standing up. And they're very sharp and they're very strong, and so when insects crawl across them, it just shreds their bodies. So that's how we get rid of them. And I'm like, yes, I cannot cause these insects enough pain. So, septarians are also a chemical process of formation, not so much mechanical deposition. Any minerals that evaporate, that are done by evaporation. Travertine, here's the big one. This is travertine. So travertine forms, what we call travertine forms in 2 different ways. One of them through evaporations of ponds, and the other one is through ancient geysers. So this is a geyser. Where we go and collect this, you can actually see the cross-section in the cliff of the geyser where it formed. And you can see the geyser comes up like this, and this is what's in it, and the rest of it all around it is sandstone. And so the way it's weathered is just cut this ancient geyser right down the center, so we get a cross view of it. It's really quite cool. Some of you have been there with me. So.
Where is this?
Down by Green River.
Crystal Geyser?
Well, Crystal Geyser it's an active geyser, but this is the same thing that would have happened. But
On the same.
yep. Mm-hmm. So this wasn't a geyser like Yellowstone Geyser. This was like Crystal Geyser, a cold water geyser. Thank you, Melba.
We can't go back.
We can do what things? We can do things. All right. All right. Oh, and tufa. I'm not making that word up either. Tufa is a real geologic thing, not to be confused with tough. Wacky and tufa. So this is a tufa. These are hard to come by, just single ones like this. This one is from a dry lake in Nevada, and as calcium carbonate and salt water mix together and evaporate, this is the product of that. And so there's 2-foot deposits that are hundreds, if not thousands of feet thick in California, in the Middle East, places like that. But this is just one whole head, a single head that just formed like that.
And what's it called?
A tufa,
Tufa?
T-U-F-A.
Just like tofu.
Looks like a giant brain.
Yeah.
Yes, yeah,
Brainstorm.
brainstorm. All right, Nope, I'm gonna pass this one
Looks
to you
like
again.
coral a bit.
It does look like coral, it's not. So there is an experiment, you can create this in your kitchen quite easily with just household stuff. You won't get a head like that.
Tufa Towers,
Tufa Towers, yep. Mhm.
California.
Yep. All right. Any questions about sedimentary rocks? Okay, so this is kind of the boiling down of a year-long class when I was in college.
Pretty cool.
So the more they're smashed, the higher, the harder they are, and the better polished they'll be. Like something like this, is that something that was at the bottom of that compression where sandstone's pretty loose?
Yeah, sandstone, so you have various amounts of, the word just slipped my mind, consolidation. So you can have sand that's not consolidated, just loose sand. That's just the mineral quartz, so it's not really a rock yet, it's just the mineral quartz. So when you compress it, then you get sandstone. So yeah, and most of them will be like that. You can have like the conglomerate, the pebbles, they get infilled around with jasper and then slightly compressed. If you compress them a lot, you get these long stretched pebbles. They're really cool, often called pudding stone. Those come from Idaho and back east a lot. I haven't seen any pudding stones from Utah. Doesn't mean they're not here, I just haven't seen any. So you can just put these on the floor, you don't have to hold them.
That's fine.
Okay, there's more to come, and they're gonna
I
get
know,
heavier.
I'll put them, I'll put the really, really heavy ones on.
Okay, so, did that answer your question?
Yes.
Yeah, so yeah, the more compressed they are, the harder they're going to be. So this, even though this one looks like it's hard, it's not really hard. So, I mean, compared to other rocks, you know, so. All right, so we're gonna move into igneous rocks. Was there any other sedimentary questions? No? Okay, we're gonna move into igneous rocks. There's two types of igneous rocks, intrusive and extrusive. Intrusive just means it cooled on the inside of the earth. Extrusive means it cools on the outside of the earth. When lava rocks, in fact the word igneous means fire formed in Latin, so it's easy to think about which rocks those are. They're the hot ones. So, the intrusive are insulated, so they're kept warm and allowed to cool over long periods of time. Extrusive, they cool very rapidly. And when I say very rapidly, sometimes within minutes, sometimes it's still 100,000 years. But that's rapidly geologically, where inside the earth they can take millions of years to cool off. So when they cool off inside the earth, because they're insulated and they cool off really slow, they can grow nice large crystals. Sometimes, they don't have to, but sometimes. And when they're on the outside and they cool off rapidly, they usually are very brittle and have very few crystals in them at all, if you can see anything. So with all that said, of course there's exceptions to every rule. So, I'm gonna start with the first one, granite. Here is granite. This granite is from the Mineral Mountains. It's made up of quartz and feldspar. And if you look on the top here, you can see there is a sphene crystal, and all the green is epidote. So those are all common minerals. The granite is typically made up of quartz, feldspar, hornfels, and mica. So the granite down there is very low in mica. This is,
Thanks to Virginia for this lovely little piece.
yes. This is granite from the temple, what we call temple granite here. It's from the temple quarry, but this is not only from the temple quarry, this is from the temple itself. When they had to do the earthquake retrogrades back in the 80s or 90s, they had to take cores all the way through the blocks of the granite, which are 12 feet deep. And I was fortunate enough to have a friend that lives really close to me here, Mark, give me a piece. So I'm going to show that. You can see each of the different colors in there is a different mineral. The gray is quartz, the white is feldspar, the black is mica, and there are some hornfels. When I say hornfels is a family of minerals, like mica is a family of minerals. It's augite and hornblende are the two. It's hard to say which one it is. They can both be there, so we just say hornfels. So,
Which
That
temple
piece
are you
looks like
talking about? Oh, excuse me.
what's that?
Which temple?
Salt Lake Temple.
Oh, okay.
Yeah.
That piece looks like a weird rice cake.
A rice cake, yes, I wouldn't bite it. It'll be a little hard on your teeth. All right, so this is a piece of hornblendite. It is a rock made up almost entirely of hornblende with some feldspar. All the white in here is going to be feldspar. So this usually forms around the edges of volcanoes with very slow cooling. Unakite is a type of granite that's made up of epidote and pink plagioclase feldspar. And so that's what that is. This is probably from China. I don't know for sure. We don't have any epidote here in Utah. Colorado has some. Virginia has lots of it. So.
We don't have any epidote?
No, we don't have any unakite.
Oh, we don't have any.
Yeah. All right, so this is an andesite. This andesite cooled, interestingly, intrusive, so extrusive. It's extrusive, so, which is why it's weird that it gets these long hornblende crystals in it. But this is from down by Hanksville, south of Hanksville. It's in the Henry Mountains.
And what did you call that again?
It's andesite. It's basically a white feldspar.
Okay.
I mean, a white granite. So. And the location's in the book if you want to go collect these. They're really kind of cool. So. All right, basalt. So usually when we think of black lava flowing out of cracks in the ground, fissures in volcanoes like Hawaii, that's basalt. Basalt tends to cool with holes in it called vesicles. If you get them big enough, you get, where'd that go?
Oh, honeycomb.
No, there's a Ziploc baggie with the ambergris in it. I moved it apparently. So if you get these big enough, the little pockets, holes, the vesicles in there are big enough, they can fill with agates, and that's where a lot of the best agates in the world come from. Here in Utah, we find vesicles with the agate-filled vesicles in the Silver Island Mountains out by Wendover. In Holt Canyon, we find lots of them that have weathered out, and if you walk around, you'll see the black basalt with the vesicles still having agates right in them. So, and the agates don't stick to the basalt because there's a clay mineral that forms in between them, so they pop out really easily and stay together. That clay is called seladenite. That one doesn't have it. But basalt can also have lots of peridot. So I'm going to pass this one around. This is a piece of basalt from Hawaii that's been turned into a sphere, and the green dots in there are all peridot. You get this also from Arizona. Lots of volcanics in Arizona that produced black basalt with big pockets of bright green peridot grains. So grainy you can actually sometimes just rake them out. Oh, Melba, can I hand you this one too?
Yep.
Thank you. All right. Okay, obsidian. I think we all know what obsidian is, right? We've all seen obsidian here in Utah. I'm going to pass around Darth Vader. He's been fossilized into obsidian. So speaking of fossils and volcanic rocks, why do we not see fossils in volcanic rocks?
Too
Because
hot?
they're too hot.
It melts them, it destroys them, yes. So you can't go from sedimentary to igneous because everything's metamorphosed. So you have to go through that stage first. So when you look at the rock cycle, it doesn't go from sedimentary to igneous without the subduction because everything gets metamorphosed in the process. So here is a piece of obsidian. This is green obsidian from Oregon. I know, I always say there's no such thing as green obsidian because 99% of the green obsidian sold on the market is just glass. So this is actual obsidian. And what we want to notice about this is that it shows a conchoidal fracture, which is very indicative of obsidian and about the easiest way to identify it. Conchoidal fracture. I did not make that up.
I know you didn't make it up.
All right, so this is one of my favorite rocks here. This is kimberlite. Anybody know what kimberlite's famous for? Diamonds, yes. So this is kimberlite. If you take it and turn it in the light, you might be able to get a little reflection of the diamonds that are in here. So, this is from Colorado.
Is this the video famous piece?
Yes, so there was a YouTube father and son that did a series. I think they still do it. It's called What's Inside, and they take different things and open it up. And one of the things they did, we cut a meteorite for him, and we cut this rock for him, and I kind of begged him to let me have half of it. So, but because there is diamonds in here, and you can see them in the sunlight, you can definitely see them. And it's from the Kelsey mine in Colorado, which is only one of 2 places in the United States you can get diamonds. So.
Can you go there?
No, it's all private property. They tried mining and making it commercial back in the 80s maybe, and they were able to find a lot of diamonds. They just couldn't sell enough of them to make it worthwhile. So.
Isn't there a place, is it Virginia that's the other place?
Arkansas, you can go down to Arkansas, it has a state park there that's
And you collect?
Crater of Diamonds.
Okay.
It's not a state park, it's a national park. Crater of Diamonds National Park, and you go there and you pay your $20, you go there, and of the 100 or 200 people that go every day, 1 or 2 people find a diamond. Most of them are a grain of sand. I don't even know how you see them. So, I've been there a few times. I never found a diamond.
Sorry,
Okay.
Rick, where's the conchoidal fracture?
The conchoidal fracture is when you get these.
Like the pit looking?
Yeah, the rings inside rings inside rings. Like when you shoot a piece of glass with a BB gun and it leaves those little rings.
Okay.
That's a conchoidal fracture.
Or when you're napping, sitting.
Yep, that's exactly. All right, this one's an extrusive igneous rock. This one's pumice. This is the lightest one I'm going to pass around tonight. So, you see, pumice is basically just a sponge. So it frothed out of the ground. It's, compositionally, it's rhyolite. It's the same thing as rhyolite. And it just frothed out of the ground and cooled instantly as this hollow, the spongy stuff full of bubbles. It's so full of bubbles that it floats. So you can throw it in a bucket of water and it'll float. So.
It's great to rub spots off your feet.
Yeah.
And to clean your toilet
Toilets,
bowls.
yep, uh-huh, yep,
Really?
Yep, oh yeah.
Yeah.
Cleans your toilet bowl really good.
yep. So I don't know where my box of these went. I just found this one laying underneath this on the floor. So this is a tufa bomb, and so this is not a tufa bomb, a tephra bomb. Tephra bombs are ejecta that are thrown from a volcano, and they fly through the air. They wind up being very spongy inside, and that's what this one is. And so if I broke it open, it would be just it would look like the pumice but black. So I'm going to pass that little tiny one around. This is a large tephra bomb. This is one that was thrown by a volcano in southern Utah, and went flying through the air, and it's got that twisted shape to it. It's very, very characteristic of a tephra bomb.
It looks heavier than the little one.
It is a little heavier, yeah. It's still,
Still light though?
yeah. So you can see that's where it landed, right there. But it went flying through the air and twisted and stretched.
I would have thought that would have been round. That's interesting.
No, yeah, many of them are not round. Many of them are long shaped like that.
What's the name of this one?
Kimberlite. Yeah. Named after Kimberley, South Africa. All right, this is a welded tuff. Not to be confused with tufa. This is a tuff, 2 F's. So a welded tuff is very glossy type of volcanic rock. It's extrusive. It has bits and pieces of the host rock that it went shattering through. It just shattered the rock as it went through it. And these are called xenoliths. That's spelled with an X. All right. If you've ever been to Crystal Peak, down on the way to Milford, between Milford and Delta, it's a big mountain out there that just stands by itself, and it is just stark white. It's a welded tuff too, and it is so bright that pilots use it for navigation. The pioneers used it for navigation, and when you're driving, you're still 50 miles from it. You're looking at that going, that can't possibly be it, and yet it is. And so it's really cool. It's stark white, but it has these kind of almost a fleshy, peachy colored dots all over it. It's really kind of cool. It's a fun place to take kids because there's lots of little nooks and crannies in the welded tough where the gas bubbles were bubbling out. They can run and hide in them. And,
Is this in your book?
of course it is.
And that's this stuff right here.
Well, that's actually from a different location. The stuff from Crystal Peak's cooler, but I couldn't find that stuff from Crystal Peak.
I've been there a dozen times and never seen Crystal Peak.
Huh.
That's why I'm gonna look it up for
Crystal
you.
Peak is near what?
Go to the Fossil Mountain on your way.
Yeah, Fossil Mountain's just north of it. It's between, as you're going from Delta to Milford, there's a sign that says Crystal Peak,
Okay.
36 miles or something out there.
Okay.
So yeah, and drive around out there. There's also what they call the Indian mud pots. There are these kind of holes in the ground that looks like somebody carved them, and they're in the colored sandstone, so it looks really cool. All right, any questions about igneous rocks? I know, again, that was like a
When you gave us a little Darth Vader, it reminded me of going out to Topaz with a group and finding what they called
Apache tears.
Yes.
Yep,
Are
Apache
they
tears.
actually Apache tears?
Oh, yes. Well, yes, because they took all the Apaches out there and squeezed them until they
Well, I
cried all
that was
over.
like a regional thing, you know what I mean? You hear about them from the Superstition Mountains.
Right. So Apache tears are okay. So backing up a little bit, I guess I got ahead of myself. So we have obsidian. Okay, we pass that around, and and here's the green obsidian, and we have rhyolite, which I'm about to pass around, which is white, and so those are both of rhyolitic composition. There was another one that was rhyolitic composition. Oh, the pumice. So chemically, these three are all the same. Okay, so but they just form differently, but they have the same chemical composition. They're andesitic feldspar based, and so if it cooled super fast, it turned into the glossy obsidian. If it had a lot of spongy air when it cooled, then it turned into the pumice. And this is the kind of obsidian, or a rhyolite that literally just had a crack in the ground and it just bubbled up and flowed. If you think of pouring soda in a glass and it just flows everywhere, it's exactly the same thing. And so obsidian is the same thing in composition. So if you go down there to Topaz Mountain, you'll find where the blebs of obsidian have weathered out of the rhyolite, even though they're the same. They cooled faster, even though they were bubbles inside of the obsidian. And the Apache tears gets their names from Apache Junction in Nevada, not Nevada, Arizona, where they literally mine those by front-end loaders. There's so many of them.
Wow.
And and they range from little tiny blebs up to yay big. And the ones that we have, we call them Apache tears in Utah, but true Apache tears that come from down there, you can hold up to the light, even the big ones, and see that they're kind of a smoky brown, and the ones in Utah are just opaque black.
Yes.
So
Okay.
maybe they're Navajo tears, I don't know.
Perhaps so.
They're not my tears.
Well, thank you. No, they aren't my tears either. I was way excited. I found one about the size of my phone.
Yeah.
And was just delighted.
Yeah, if you drive up Starvation Canyon, it used to be called Cyril Canyon. I don't know why we had to change the name. But if you drive up Starvation Canyon, there's a just on the bed, the riverbed there's a place where you can see the rhyolite flowed. You can just see where it flowed, and the obsidian blebs are still in there. The Apache tears are still in the rock. So that is not in the book.
Starvation Canyon.
Yeah.
But it's
All right.
on the map is Searle Canyon?
Yeah, well, it used to
Southwest corner
be
of
called Cyril Canyon. Now it's called Starvation Canyon. I guess somebody died in there from starvation. I don't know.
I've seen Searle. I haven't
Maybe
seen
Searle.
the other
Oh, okay. Well,
one.
yeah. Most of us just call it Cyril Canyon. So this is rhyolite from down in that same area. In fact, Cyril Canyon, and who knows what that's famous for? Topaz and Bixbyite and
Amethyst.
amethyst and
Red Barrel?
red beryl. Yes. So this one has a little red beryl stuck right down in there. I'm going to pass that one around. This is one I think we found last time we were out there. So,
Where was that you found it?
Cyril Canyon. Yeah. So Starvation Canyon. Yeah. So that's actually a private claim, so you can't actually go there. But if you go over to Topaz Mountain and dig up there where it's notched, you can find them up there as well. So.
John's claim.
This is from John's claim. Yeah, John and Jeremy. All right, any questions about that before we move on?
It's a great little red barrel in there.
Yeah.
That's fantastic.
Yeah. Okay, okay, good. All right. All right, so metamorphic rocks. Metamorphic, meta means change, morphic means rock. So what causes the change is heat and pressure. And if you think about that, there's a lot. If you take the chemistry of a rock and mix it with heat and pressure, there's almost an unlimited amount of possibilities. So, you know, every few degrees with the same pressure can change the rock. Every few kilobars of pressure at the same temperature can change the rock. Chemistry plays a big role in it, so it changes everything. So that's why, you know, there's about 8,000 minerals now. Is there 8,000? 6,000? I can't remember. Either 6 or 8,000. It's got to be 6,000.
So is that like quartzite style, right?
Yes. So about 6,000 minerals. There's probably 100,000 rocks. So, yeah.
So this is the biggest category.
It's by far a bigger category than the minerals. So when we say heat, metamorphism starts at about 300 degrees Fahrenheit and it goes up. Obviously, if you're melting the rock, you're several thousand degrees. 100 bars of pressure, 1,000 bars of pressure. That's 1,000 times more pressure than you feel on your skin at the surface of the earth at sea level. So here we feel a little less than what you feel at sea level. If you go down deep, 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 you can obviously feel more. Anybody who's ever been underwater can feel the pressure against their lungs and stuff. So changes can be mineralogical, textural, or foliation. So mineralogically, you can have a mineral change from one type of mineral to another. That would be the sphalerite and wurtzite. At depths, it's wurtzite. You bring it up, it literally physically changes the molecular structure into sphalerite. Texturally, you can have sandstone be compressed from grains, or sand compressed to grains, of sand compressed into sandstone, and then sandstone compressed into quartzite. Here is a quartzite that had that exact thing happen to it. So, this has got a little bit of a green cast to it. This used to be sold as flagstone. See it on a lot of buildings and stuff. Some minerals or some rocks changed from limestone. The black limestone, if it is compressed, it goes through a alteration it's called metasomatic alteration, and it changes into marble. So here's a piece of marble. This is also from down by Milford. So not a piece of Carrara marble. I can't find that. No. But Carrara marble is a very, very fine-grained porcelain-like marble. That's why it's so good for carving. It's very, very even throughout. This is not quite that good. So, gneiss and schist. I'm not swearing. All right, here's a piece of schist. I'm sorry, this is a piece of gneiss. So, this is gneiss.
They're bad.
Yes. This is a nice gneiss. And we have a schisty schist.
And then there's not nice.
So,
Not nice. Everything else is not nice.
nice, right? So if you take granite and you compress it, the minerals in granite start to separate. You get the layers of quartz and the layers of, in this case, mica and the hornfels separate out. So you get the layers of them. And I'll pass this one around. And you can see that not all of it has gone completely through. So it needed a little bit more pressure to separate it out completely, but it started. Oh, sorry.
That's okay.
All right, here is a garnet schist. These has big garnet crystals in there, and it has the starlight crystals as well. So one of the things that happens is this is a mineralogical change. You take a schist like that, you can press it even more, harder and harder and harder, give it a little heat, and you start to get garnets that form. They grow literally from the rock that makes up that into this.
Is that from Dutch John?
Dutch John, yes. So, you got
Show
garnets.
the backside too.
Yeah, some big garnets back there. And dirt from being out in the yard. All right. Of quartzite marble. And one of my favorites is a dactite. Oh, this was This is igneous. I missed this one. Igneous. This isn't metamorphic. Dang it. All right, we're going to go back to extrusive igneous. Dactite. We also call it Monroe agate. If you went down and collected the Monroe agate with us last week, 2 weeks ago, last week, whenever we were down there, 2 weeks ago. Yeah. So this Monroe, Marysville. So this is the agate, and it has, so this flowed out of the ground, out of a rupture that, like a toothpaste. It was squeezed this dactite out. So we, geologists will call it a dactite. Rock Council will call it agate. So it's the same thing. It's a jasperoid. But in this case, as it was forming, it got a thick layer of hematite over the top of it. And you can see the hematite in there. It's botryoidal hematite, so it's really kind of cool. Some of it's very glossy, some of it's red. All right. Did I cover them all? I think I did. Any questions?
I have a question on rhyolites.
Uh-huh.
So out in the desert, there's a lot of that.
Uh-huh.
But the topaz crystals are only at Topaz Mountain. Are there other locations? There's the rhyolite that looks like this
Uh-huh.
all over the place.
Right, you're right. There's a number of different deposits of it out there, and where you get the big red burls and the wawas, you don't get the topaz, and it has to do with the chemistry. So it's obviously deficient in the boron. Is it boron? I think it's boron. So, what?
You look at me like you're ready to give me the answer. Yes, it's deficient in the boron. No, but we were, when we were at Marysville, we stopped and there's a rhyolite flow that has the amethyst crystals in it.
Amethyst Bixbyites. And not the topaz. Oh, it did have topaz.
Did it
Yeah,
have some topaz?
we did find some topaz. They're all little micros. So
But they're really cute.
Yeah, you can't look.
They were really cute.
They were really
Yeah.
cute.
So where did you find that amethyst piece that you have out there when you were in Marysville?
So that piece next to Zeke's rock, there's that piece of rhyolite. No, out in the yard on the driveway. Zeke's big rock, there's that rhyolite flow.
yeah, that's from where we were digging the amethyst and
Where
Bixbyites.
at?
It's in the book.
Huh?
It's
it
in of course it's in the
Okay.
book. Yeah.
That wasn't 2 weeks ago.
It's not out there by
Yeah.
the rock
We didn't pick it
shop,
up.
is it?
Yeah.
Yeah, we did.
Oh,
Yeah.
I must have missed you, Stephen, borrowing, getting that.
No, you were there, weren't you?
That one
I didn't
has nothing
see
to
it.
do
you
with this
didn't?
class.
Must be after I left.
Oh,
what's
and we
it
took
called
that piece
again?
back.
Well, it's if you look up Marysville, it's the amethyst and Bixbyite location.
Monroe agate
The Monroe agate.
Monroe agate, okay.
Well,
or dactite.
dactite. So that's not where that is. The dactite. The rhyolite, like that flow one out there, is over. It's on the other side of the freeway.
Oh, okay,
Yeah. Yeah.
okay.
It's a little bit of a hike,
You
but.
can see the keel of another one.
Mhm.
Straight up.
I don't know, mine is still in my backpack.
Is it? No, I probably have it.
All right.
I picked it all up.
Any other questions?
Some little tiny pockets.
Is quartz monazite a metamorphic?
Quartz monzonite is an intrusive igneous rock of granite that is, so monzonite is a quartz deficient granite. It's a very specific type of granite that's quartz deficient. So when we say quartz monzonite, that's what the temple granite is actually. And so it's a monzonite that just happens to have a little bit of quartz in it. Yeah, I don't know how they figured that one out. I'd have just called it granite. There's literally like 4,000 types of granite.
Right. Black light?
I don't know them all. I don't know like 3.
I got them when we had the.
So the things down at Goblin Valley, are those sedimentary?
Yes. So those are sandstone that have a high clay content in them, and because of the way they were formed, because when that whole area was filled in, there was a little bit of compression and a little bit of moisture, and it created these nodules. So they're not concretions. They're not septarian concretions. They are concretions. They're not nodules. They're concretions, and so they're hardened all the way around, all the way through. But it has to do with compression in the groundwater, and so when everything else eroded around them, those were harder and they stayed, creating those hoodoos. Oh yeah, Yeah, Utah has a lot.
So,
Black light and
I have probably a basic question, but I saw downstairs you had a bunch of Moki marbles. Explain to me how that happens.
I think I did explain, but I think you were in the other room choking your lungs out.
Oh, I was actually.
So if you have sandstone, the red sandstone of Utah, which is